Howdy, my name is Fosak, software developer at WorkSync, and I'm going to talk about Servant today, which is a Haskell library for describing type-safe web services. All right. And my slides are out of sync immediately. Awesome. Just a second. All right. There we go. I'm going to start with just what you would it is how they build libraries, what they and then have a code like that. Get I also side querying functions for each endpoint. So when I first discovered Servant, it was in the context of using it to build API web servers. However, it's all useful for generating documentation. Like here it says side query functions, that's like generating JavaScript you hit the API described. So it's used both for building servers and for building clients. Why might you want to use Servant? It is very concise. They take this to the extreme. So you define your API once, and then you get to use that same API description for the server, for the client, for the documentation, for everything. So you don't have to repeat yourself all over the place about what this endpoint expects and what it'll return and where it is and all this kind of stuff. It's also very flexible. You have to use Servant, obviously, to get all the benefits from this, but you can use pretty much any other library you want to, and it'll plug in nicely. So you're not stuck to like one HTTP server or one, I don't know, text processing library or regexes, or like how you handle your parameters or your XML or your JSON. You can do whatever you want to. They're not tying you into any particular one. Servant also is very good at separating concerns. So the way they talk about handling an HTTP request is with a handler. In Rails, this is like an action and a controller. And inside of there, you basically don't think about HTTP at all. At the API level, you specify what your input types are and what your output types are, and it'll handle converting everything. Like if you say, I accept JSON and I return XML, in your handler, you don't have to think about parsing the JSON and rendering the XML. You just you take in an object that's already been parsed and you return an object, and Servant will take care of converting it to XML for you. And lastly, the main reason why I'm interested in Servant is the type safety. So you get compile time guarantees about the types in your API. So if you're implementing a server, you can have your API description that says, okay, if you do /events, you're going to get a list of event objects or values. And you can be sure at compile time that you're actually returning that from your server, which to me is really cool. It makes sure that the API specification you've laid out is actually being implemented correctly. And to me, that's very powerful. So before we get into the weeds, I want to show you all what it looks like with a simple example. And so this is an entire implement a server. And the way you may do that is to say, okay, this first line here says, I'm implementing a server and it has the type of that API I described on the last page. This is what will do the type checking at compile time. So if you mess up this server, it won't compile. Normally in your server, you would go hit a database or something, maybe do some extra querying. For this example, we're just going to return a static list of things, and we'll build up these person objects and put them into a list and then return them. So not a lot going on there. Again, this is a simple example, but it's all checked at compile time to make sure that you're returning the right thing. Another cool thing you can do with the same API without really doing any extra work is get Haskell functions that will hit that API for you. So let's say you're running the server that we built on the last slide, and you want to make requests to it in Haskell. You can do that with this code right here. So this first part, we define essentially a value level way to get at our type level API. If you'll notice back on this API description slide, we define it as a type. This isn't a value, it's a type. So if we want to pass that type around to functions, we need a proxy. And what that means is it's a value that only has one possible value. So the only interesting thing about it is what the type is. So in this case, the type is the API we described. So when we pass it to a function, that function will know about the API we described. This is kind of a little bit above my head, I have to admit. I haven't done a lot of type level programming in Haskell. But essentially what this means is the proxy is the way to talk about your type level API at the value level, which is where most functions operate. So with that API, we can define this getPeople function. We don't have to say the type of this thing. I'm just doing it for clarity here. It would infer the type for us. And then we assign that to the result of this call to client, which is something that Servant provides. And we pass it in the proxy for our API, so it knows what endpoints to generate. And then we pass in the host, which is basically the location that the API exists. So if you have it at api.example.com or apiv2.example.com, you can switch that around without too much fuss. And the return type here for getPeople means that it's either going to return an error, this servant error thing, or it's going to return a list of people. And it's going to do that in the IO monad, which means that it'll actually go out into the real world and make an HTTP request and get it back. So this is how they handle error. It's not through exceptions or through anything like that. So if you try to make a request and the server's not there, you'll get back a servant error with the appropriate description. Yeah, you have a question?
All right, so that reads either servant error or person wrapped in the IO monad.
Not quite. It is wrapped inside the IO monad. You will either get a servant error or a person or a list of people. So yeah, the order is a little difficult to read. This isn't something that Servant has done. This is another library. Either T stands for either transformer. So I think I talked a while ago about monad transformers. I don't expect y'all to remember everything, but the basic idea is that you can layer them on top of each other. So at the bottom you have IO, and then you layer this either thing on top of it, which says that you get either this thing or that thing. And then you can compose them together with these transformers. The ordering of the arguments is just kind of, I don't know why they're that way. I would guess historical accident. There may be a good reason, I don't know. But typically what you would do is define an alias that says all of my client functions look like this with this one value part to sub out. So you may say like, action is either T servant IO something, and then you can plug that something in over and over again. Any other questions about this so far? So this is literally all the code you need to generate the client function that'll hit the API we described. It does everything else for you. It does converting it from JSON. It does making the HTTP request. It does setting up like a manager to do all these HTTP requests. It's really powerful. Yeah.
So presumably there's some way it looks at the return value to make it, to turn it into JSON, transform it?
Yep.
Is that something you can control?
Yeah, so when you define a type like person in Haskell, you would have to define how you want it to be converted from JSON or to JSON, in this case from JSON. But so that is in your control. There are a lot of automatic functions for doing that. Like if your data looks in a pretty, or it looks pretty normal, you can derive it automatically and it'll do the right thing. But but the JSON that it gets back from the request, or not, maybe if it's not even JSON, it'll blow up and say, I couldn't parse this. Or if it gets back JSON and it doesn't know how to convert it into a person, you'll get back an error that says, I tried to convert it, it didn't work, here's why. Does that answer your question?
Yeah, I'm just trying to think if you were to add like pagination links, right? Like rel kind of stuff.
Yeah, so if you wanted to do that, you would probably create a wrapper data type that would return like a person and some metadata, or a list of people and some metadata.
Paginated thing.
Yeah, and that again could be abstracted over the type of thing that you're paginating over, so it would be a more generic structure. But yeah, you would have to be a little bit more explicit than probably you or I are used to most of the time, where you're like, just return some JSON blob and then parse it and get these fields out of it. You have to be very particular about which things you're going to return. Any other questions? All right. So this is how we would generate a Haskell client, but I know that not everybody uses Haskell, so you can actually generate a JavaScript client, and it's even easier. They provide this function called JS for API. You pass it the proxy for your API, and it will generate a string that is the JavaScript code that you can use to query your API. So this would generate a function called getPeople that takes no arguments, because there's no arguments to pass to the thing. And it'll go make a request. It happens to use jQuery, but they're also supporting native JavaScript and a couple other libraries. And they're actually pretty easy to add. I looked at the source code for all these. So like if you wanted to add one that uses super agent, you could probably do that without too much trouble. And the idea here is that you might have your server somewhere that hosts your API, also hosts the documentation for it, and maybe also hosts a JavaScript file that you can download that would be the basis for the client code that you might use. So you would return this from some endpoint and then cat it together with a bunch of other JavaScript to make your actual library for consuming your API. And let's see, I don't have an example of the type of JavaScript that it would create, but it's all pretty straightforward. You know, you have the verb of your HTTP request and then some type of form of the request path. So if you have like foobar baz, it'll be get foobar baz. And then you have a parameter list with all the parameters you've defined, which we'll get to in a second. And then it does the AJAX request, so like $.ajax and all that jazz. And the last bit that is provided for free is Markdown documentation. So again, using the same API description as before, and very similar to how we generated the JavaScript client, we can generate Markdown documentation that explains, like, you can make a GET request to this endpoint. You'll get this type of thing back. We accept JSON, XML, whatever. The only thing you have to add that we haven't had to do for anything else is we have to tell Servant how to generate sample data for this, the types of things that we're returning. So this is exactly what would show up in the documentation when it says, like, you can make a GET request to this endpoint. This is what the response will look like. So it'll just be this exactly. So you get very fine-grained control over that. Also, if you want to, there's a bunch of options you could do on this, like including a header above all your Markdown stuff. So if you want to have like a high-level description of your API, you can do that. But yeah, it's pretty powerful. Again, you describe the API once, you can generate a server, you can generate JavaScript client, Haskell client, Markdown. Very cool, I think. All right, so what? I think this is pretty cool, like I just said. But I want to explain why I think so. And the first reason is that I feel like this is a force multiplier. You get to define an API once, and then you get to use that definition to get a lot of other stuff basically for free that would take a lot of manual, tedious work otherwise. Also, you get to make sure that everything actually stays up to date with each other. So if you change your API, your documentation isn't going to fall out of date because it'll automatically be up to date. And if you have some part that you don't provide an example for, it'll tell you at compile time that it doesn't know how to create a sample for that thing. This is really cool to me because I hate it when our documentation is out of date, or you have some Ruby code that calls your API and it expects something, your API has changed and now it does the wrong thing. Another thing that I really like about this, which should be no surprise to anybody that knows me, is that it's very explicit about what it expects. You have to spell out exactly what your API looks like and what the endpoints are, what formats they'll take in, what formats they'll put out, all the query parameters they need, all the request body, all the return types, everything. So it's very well specified, and that means that there's no room for anything to sneak in where you're like, oh, well, for this one endpoint, you have to do this other thing that's not in the documentation. This happens a lot to us where our API documentation doesn't cover something that the code actually does and that some people actually use. It's just not in the documentation. So this makes it very clear how the API should be used. Another benefit is that this will help support service-oriented architecture because you get all your client libraries for free. So if you had, let's say, a bunch of APIs implemented in Haskell with Servant, then you could call all of those APIs from each other pretty easily because you get the client code for free. And you get to be sure that everything, again, works at compile time. And it's not restricted to just one language. So if you were, had a bunch of Node services and some Haskell services, you could call your Haskell services from Node with the code that you've generated in Haskell. And the last part, which kind of dovetails into that, is that it's extensible. So if you want to add a new generator for like Rust or Elixir to generate client code in those languages from Haskell, from this API description, you can do that, and it's not too hard. I've actually started implementing one of these for Ruby, and I've been working on it like 2 days, and it can already make simple HTTP requests to endpoints that are described via Servant. It's awesome. Also, this means that like if I work on my Ruby thing and it turns out to be pretty decent, the rest of the community that has Servant APIs automatically gets like a robust Ruby client for free. They did nothing. They just add a new dependency, they'll get the whole Ruby client. All right, so that's all fine and good, but what does Servant actually look like in real life? APIs can and frequently are complicated. So they have lots of paths, they have lots of query parameters, they have request bodies, they have headers, they have a bunch of crap. So I made up a very complicated API that uses pretty much every feature that Servant has, and this is what it looks like. I'm going to walk through these one at a time, but this is more or less what a complicated API description would look like. So each line is a different endpoint. This funky looking combinator that's like colon, angle bracket, pipe, angle bracket means or, basically. So this is saying, for my API, you can get this endpoint, or you can get this endpoint, or you can get this. One way that you would make this read a lot better is that you would give all of these types more readable names. So the first one might be get deeply nested things. So then on this line, you would literally say type API equals get deeply nested things, or get whatever the next thing is, or get whatever the next thing is. All right, so the first part is deeply nested routes. This should be easy to predict based on the first example I showed you, where if you just add more of these little smiley face emoticon things, you can get deeper and deeper paths. So this is like /deeply/nested/things. It returns a list of JSON things. One very common thing is capturing variables in the URL. So one particular part of the path might represent an ID. So the way that this works is you say capture and then the name of the thing. So like in Rails routing, this is where you do like :ID. That's what this means right here, this first argument. And then int is the type that you expect for that thing to be. So it will convert that automatically from the string in the URL to this integer type. And if it fails, it'll 404. So you have type safe routing at the variable capture level. You don't have to handle this in your router. Or sorry, in your handler. And then again, this is the first example we've seen that doesn't return a list of things, it just returns one thing, but it works exactly the same. I was actually surprised Servant taught me about something that I didn't know about called matrix parameters that are in URLs, and they're part of the query. So, or sorry, part of the path. So this matrix flag is on the CGI part of the path. So you do CGI semicolon bin, and that would mean that you've passed this bin or this matrix flag, and it should be set to true. So this example here on the slide where it says /a semicolon matrix, that matrix is a matrix flag, which is a thing I've never heard of before, but apparently exists. But definitely the more common one is query params. So I'm going to try to focus on that. It has three ways of handling query parameters. The first is with the flag. So That would be if it's not there, it's false. If it is there, it's true. The next one is query param, which is a single like scalar value. And then query params is a list of values. And it'll handle those either by repeating the key name. So you do like it says here, foo equals bar1 and foo equals bar2, or you can do it with the square brackets that Rails and a lot of other things expect. Either way works. Again, these get type checked, so your handler doesn't have to think about it. It'll just get, you know, the list of strings in this case for network. Are there any questions about this? The matrix params kind of threw me for a loop the first time I saw them, but they're not terribly important because most of the time you'll be using query params. All right. So another thing that your API could depend on is request headers. And that's like, okay, to access this endpoint, you have to pass the cookie header, and it has to be interpretable as a string, which pretty much every header will be. And again, this is where you have to be very explicit about what your API expects. So this is probably something that we would typically not document in our API docs, because we would just assume that if you did cookie-based auth, then you'd be passing the cookie parameter around. But we have to be very explicit about it here. Another very common feature is request bodies. So if you're making a post request and you want to upload some data, you're going to do it through a request body. What this says, it works very similar to the last bit here, but it says, I expect a request body, and it has to be either JSON or XML, and that JSON or XML has to be able to be deserialized into a person value. And again, you can define these serializations however you want. If you wanted to wrap them up in some extra data, you'd have to define a new type to do that. And then this says that although I accept JSON and XML, my response is only going to be JSON. So you can very easily accept multiple kinds of data types. If I wanted to return JSON from this, I could just add comma XML to the last part over here, and I would get XML. And we saw the request headers a couple slides ago. If you want to add response headers to your response, you have to specify those in your type as well, so your clients will know to expect this header coming out. Works in basically the same way. You end up wrapping the return type for your handler. So by default, I might just return a string here, but then I wrap it up in this headers thing, and I'd say which headers I'm going to be returning, and then also the return type. And I've mentioned this a couple times already, but content types can be specified for the request body or for the return. And when you have a lot of them like this, you actually end up generating a very powerful thing just sort of by virtue of being able to serialize or deserialize into all these formats. So somebody could post a JSON thing, and then they would get back an XML thing if that's what they wanted, or a JSON thing, or an HTML thing. And your handler doesn't think about it at all. Servant has actually implemented a image, let's see, like a converter between ping and JPEG and GIF and bump, just by a line like this where they say, we'll accept pretty much anything and then we'll return pretty much anything. So you specify what you want and you'll get it. So if you want to convert your ping to a JPEG, it'll do that. Your handler literally does nothing. You know, it just returns the thing that it got back, and Servant handles deserializing and serializing for you. It's also worth noting that you can add new content types pretty easily. So all the image things weren't actually defined by Servant. They're defined by a different library called Juicy Pixels. And then you just plug them in. It works great. And finally, the last part, well, I guess not the last part, but getting toward the end here, of Servant is that it's very good at reducing duplication. So we've already seen that it's pretty succinct in terms of like describing endpoints, but if you have a lot of endpoints that share a common structure like these two do, then you can extract that out very easily by defining a type alias. So I have these two endpoints, which are actually examples from the @Astra API. These are pretty much real examples. So you can get a user by ID, or you can get a person by ID, and they have a different part in the path, and they return a different value, but otherwise they're identical. So I can define this type alias called getEntity that is varying on those two things, the path component and the kind of the thing that it returns. And then, boom, I can shorten these two definitions, and they get a lot more clear about what they're doing and what they expect and how common they are. So being this explicit is great for me, I think, but it can be bad because sometimes you just want to get something done very quickly and you don't really care about correctness. And it's still possible to do with servant. So you can add this raw thing as the last part of your API. And what that says is, if a request doesn't match any of these previous endpoints, just hand it off to the server. So when I define this API here, I'm saying that I will implement a server that does these endpoints, and then there'll be another server that can handle everything else. And this is very useful for like serving static files. So you could define your API, and then everything else could be a static file that falls through to your HTTP server. Or if you have, you know, a completely different website available, like you have an API and you have some type of marketing front end. Marketing front end can be served by this raw part. Everything else goes through your servant API. So you're not locking yourself into this rigid defined API structure just by using servant. You do have an escape hatch. And this is actually the last thing I have to talk about. So if you have two APIs, you can define them independently, and then you can combine them together into a higher level thing using the same stuff we use to build endpoints. You can use to compose APIs together. So I have, you know, some API v1 that defines a bunch of endpoints, some other API v2 that defines a bunch of endpoints. I can mount them under API/v1/whatever all those other endpoints were, and then the other one under v2. So I think this is really cool because the API v1 doesn't need to know that all of its endpoints are namespace with API v1. It can be put wherever you want. That's actually all I have in terms of slides. Does anyone have any questions about what I've covered? I do have an example to go over that we won't be on the Hangout on air, but we'll get into that if nobody has questions.
Can you customize the error? You know, you said if the routing doesn't match, you get a 404, but like on our API, sometimes we have the hypertext that says, you know, oh, this is the wrong path.
Right. So the question is, can you customize the error messages? And honestly, I don't know. I know that you can customize. So if we go all the way back to this thing where we have this either T servant error IO person, you can customize what the type of this thing will be. So you can say like, oh, I'm going to return my own personal kind of error. But I don't know how to customize what errors happen over the course of like default handling. I'm sure that it is eventually possible. I don't know how much work you would have to do to make it happen. But that's not, it doesn't seem like that's a priority with the servant library so far. Like they want to handle all the stuff that you define at the type level will be handled in a certain way, and then once it gets handed off to your handler, you can do whatever you want. But it has to meet all the prereqs that your API describes. No more questions? All right. Let me kill this Hangout here.